I think there was a small glitch. No. It was a small glitch, I think, while handing it over. Don't worry.
I'm sorry, I left by accident. I'm back here.
No, it's okay. That's fine. I've got some messages on Discord. I'm gonna tell them to join again. I'm just texting. Join again, please. It was a small glitch.
I'm so sorry. I just wanted to stop the presentation.
No, that's fine. It's okay. It's okay. It's all right. I'm letting everybody in. I'm letting everybody in. Please join again. It was a small glitch. So I'm the host currently because the problem is Eda had to be the host so that she can present, and now I have to be the host so that I can present, and in between that can happen. So I'm gonna let everybody in to the Zoom room. So I'm just gonna wait a second, and I'm gonna make some people co-host. I'm gonna make Farhana co-host first of all. And then I'm gonna make, I think Rehab also joined, Rehab from Her Will. I'm gonna make her co-host as well. So I think right now it's only me being host. So I need another host. So I find another one, Sanjida from Her Will. No, wait a second. I'm gonna make Farhana Hassan as co-host. No, a host, I mean host. Yes. Farhana Hassan, you are host right now. And I have Rehab as co-host. I'm going to make Eda as a co-host as well. I think you are already co-host somehow.
Not anymore. I was co-host, and then.
Oh, okay.
But maybe
Yeah,
I don't have to be co-host anymore, and maybe it's safer if I'm not.
that's
But
okay.
I never did this before. I'm so sorry. It was just yeah.
This is totally fine. It's totally okay. So there was a question from Tasniha. Are we gonna have a break? Yes, we can have a break for 5 minutes if you want. And I'll start with my presentation momentarily. I mean, it's up to you because my presentation is going to be a little bit lengthy, I think. We can go for a break. Yeah, let's go for a break for 5 minutes for everybody. I'm gonna stay here. I'm gonna be muted. I have a raised hand here from Mahajibin. Do you have a question?
Yes, Apu, I have a question. Can I?
Sure, please go ahead.
Apu, is the datathon will be designed like Kaggle competitions or like that? I'm a bit confused about the process of datathon.
It will be a Kaggle. It will be a Kaggle competition. So you will get all the specifications and all the rules and regulations on your last workshop, which is on Friday next week, on April 22nd. Um, so the whole thing will be hosted on Kaggle. That's it. All you need to know is that you are working on Kaggle. So I've already prepared my presentation here. I hope you're all joining back again. I'm just saying, whoever was there on the last workshop, you saw that I was pretty sick. I was coughing a lot, and I took a short vacation in the Canary Island, and it's magnificent weather, sun, sea beaches, and everything, and it worked like magic for me. I'm pretty much recovered now. So yeah, it's in Germany we have Easter vacation on Good Friday and also on Easter Monday. So we have vacation from Friday till Monday. So I was thinking, okay, these 4 days I can simply just go to the sea, go to the somewhere sunny. And yes, here I am in the Canary Island. It's in the North Atlantic, pretty much near West Africa. Uh, it's nice here. Um, all right. So I think I'll begin. Um, okay, so I'm starting with my part. So yeah, my part is about feature engineering and classification, or mostly the part of the classification that I could not explain properly during our last workshop. So let's start with feature engineering. So you see this diagram here of what data scientists spend the most time doing. If you calculate, if you count up the first three points, you see like the building training sets, cleansing the data, and then collecting the data sets. That's kind of more like 80% of the job. And afterwards, you see the data mining data for patterns, refining algorithms, and others. This is the prediction part. So you will be busy with data cleansing and the training set like 80% of your time. Uh, yeah, you have to understand exactly that's why feature engineering is important. So just a question to the co-hosts and everybody. I think uh, we are the video is working, right? I think yes. Can anyone confirm if the video from the hosts and okay, okay, good. Yeah. All right. So here's the thing, like, why do we need feature engineering? So um, the thing is, like, you have a training set and you have features. Let's put the training set as a table or a matrix. So the columns, most of the columns, those are your features, and then you will have only one, like one or two, like let's say one target column. That means that you have the information for the target in your training set, but the information is hidden in the test set. So that's a target column. So except for the target column or the ID column, everything else, all the columns, those are your features. So we want to make sense of all those features. How can we refine the features for our prediction model? Uh, let's say our training model, not the prediction model, our training model. So um, all the features, they must have a relationship to the target that your model is able to learn. So that's keep that in mind. And I'm going to show you since we're doing only basics of data science here. So let's stay with linear models. So it's also like linear models are only able to learn linear relationships. So if you are using a linear model, your goal is to transform the features to make the relationship to the target linear. It shouldn't be quadratic or like something complex or something like that. And if your model is quadratic or even more complex, then your features should also have the relationship to the target exactly on that scale. So, how do we do feature engineering? Oh, just yes. Why do we need feature engineering? Obviously, these are the 5 points that I could think of, and these are really important points. If you do proper feature engineering, regardless what kind of prediction model you're doing, how you're training your data, the training data that you have as an input, it's never tidy. So you can see like in the 4 point, I wrote down this keyword tidy data. So you have to make your training set tidy. So if you can do that, it will improve your model's predictive performance. It will reduce the computational needs. It will improve um, your runtime. It will improve the interpretability of your results. And obviously, there are like lots of ways of feature engineering. So these are the 6 points. There are many, many steps for feature engineering, but these are the basics that I can think of. So you have got imputation, one-hot encoding, date extraction. Date extraction is very, very important. You have grouping, binning, and feature split. So I'll start with imputation, and I'll also explain why imputation should be the first step, because imputation is basically the method of how to deal with missing values. You will have training sets, you will have data sets with lots of null values or missing values. What to do with them? How do we deal with them? So there are, I can summarize the whole thing in three um, steps, I would say. So first of all, you can always drop those rows or columns before you train your model in your training set. If you have one whole column filled up with nulls, you just drop it, or rows with nulls, you just drop it. And lots of machine learning algorithms, they do it automatically during the training phase. But the problem here is if you drop one column or on one row, it will reduce your training size, your training data size. But you can also do it manually if you have rows or columns with mixed values, like there are some values and there are some null values. In that case, you cannot drop the columns or the rows entirely. You have to like think about something else. But if you do have completely null columns or rows, you can just simply drop it. That's because if null means the value is missing, but it won't actually contribute to your prediction at all. So you can just drop it. So what are we gonna do if we have mixed values, like we have missing values, but some other values as well in a row or a column? Yeah, so in case of numerical features, this is more preferable than dropping, because in that case you have the data size is preserved. So what you can do is you can use 0. This is a trivial value. You can use 0 for nulls, but you will always have to keep in mind that null is never 0. It just means that the value is missing. So if you're doing descriptive analysis or other stuff, you will always have to keep that in mind, and you will have to create a chart, or you have to gain some insights of the data without dropping the nulls. You have to keep that in mind. But if you have something like a binary column, if you see that there are only ones and zeros and nulls, you can, let's say, trivially put 0 as nulls in your column so that you can preserve those, the size of the set. But if you have like other values than 0 or 1, let's say 1 point something, 3 point something, or whatever, some numerical values, then I would recommend you to use the median of that column, of the whole column. I wouldn't recommend average because average is not that robust. Median is more robust than average. Um, Average, like anything you put any value, it will change the whole average of that feature. So that's why I would recommend to use median in case of numerical imputation. Okay. There, I got a question. Would you please tell me what threshold meant in the, okay, so the threshold is, so basically, before you start preparing your training set and start with your model, what you do is descriptive analysis. And while you are doing descriptive analysis, you run lots of codes, like to find, as for example, find out the significance of a feature. So you will see automatically that there is a threshold. Your significance value will always give you a threshold, or you can yourself find a threshold. As for example, let's say average age of a woman to become pregnant, depending on countries. Let's put it that way. So let's say threshold of women becoming pregnant in Bangladesh is 25, or threshold for women becoming pregnant in Germany, 35, let's put it that way. So that is your threshold. Threshold is just a balance that, okay, everything beyond, if you have any null value there, or any missing value there, you can just simply put the median, or you can like drop everything which is above the threshold value of something. It's just arbitrary. The 0.7 has no meaning, but the threshold is something that you have to define all the time. Um, does that answer your question, Azra? All right, cool. So let's move on to the categorical imputation. You also have categorical columns. We already discussed categorical data, numerical data on our second day of our workshop. So you might not have just numerical data. So numerical is fine because you can always either put a 0 in case it's a binary column, or you can simply put the median, as I discussed before. What to do if it's a categorical data? What to do if you have a training set, if you have a data set where you have, let's say, gender, column gender? What are you going to do about that? You can't just put 0 or 1 or some other numbers in case of missing values. So what I would suggest is, if you see that in gender column, let's say it's about salary, it's about average salary with respect to gender. So if in that case, you have to understand that the training set is coming from one source and they've done their research. You'll just have to, like, have faith in that all right, they've done whatever they can do, right? They've done it as far as they can do. And if you see that in case of missing values, the gender, like female, like lots of missing values are there. No, you should, a good data set shouldn't have lots of missing values. Let's say like you have a set of 1,000 persons, 1,000 people, and a few gender is missing. So in that case, I would recommend to take the maximum occurred value in that column. Let's say male would be the maximum occurred value. In that case, you can put male. But in case if you see, that's why descriptive analysis is so important, and I cannot stress this point enough. You need to understand how the values are distributed. If you see that female and male both are distributed uniformly, in that case you cannot just assume that those missing values are either male or female. In that case you just put other or something else, like not available. Write something down, uh, give it a string, put a string name, something there, not available, missing, or other, something like that, instead of null, because null is never good for a prediction. Never. Um, so that's about imputation, and we're moving on to one-hot encoding. Any questions so far about imputation? All right, moving on to one-hot encoding. So in my life as a data scientist, I have used one-hot encoding almost every time. Always. I mean, my first step was always imputation, dealing with the missing values, and the second step was always one-hot encoding, like as if it works. It doesn't mean it's. Oops, sorry. Um, it's not like written in stone or something like that, but one-hot encoding is very useful. So, what does this one-hot encoding mean? It's basically transforming a categorical data into numerical format. So if you can take a look at this, the left side table, you see there are users like user ID. So we have a user 1, 2, 1, 3, 2, 1, 1. So let's say there are 3 users or user ID from a travel agency, tourist or someone. So we see that the user 1 has been to Rome. User 1 has also been to Madrid. User 1 has also been to Istanbul and again in Rome. User 2 was in Madrid and also in Istanbul. User 3 was only in Istanbul. So if you feed this left side table into a machine learning algorithm, if you use any kind of machine learning algorithm, they will give you something, but it's not as efficient as if you could transform it to a numerical format. So what you have to do is you put down the user IDs on the left side, that your ID 1, 2, 3, and then you just transform the rows, the cities, into columns. So you have 3 columns in this case: Istanbul, Madrid, and Rome. And you just put down 0 or 1 as like binary. Yeah, user 1 has been to Istanbul, has been to Madrid or Rome, and so on. So we can see in case of user 1, user 1 has, well, there is one missing column. I didn't put it there. Rome. You could have like put Rome there. Like you could just like Istanbul. User 1 has been to Istanbul, uh, or not, or like to Madrid or to Rome and stuff like that. You can just like transform the rows into columns. And in case of okay, this user has been to Istanbul, yes or no, you put down 0 or 1. Madrid, yes or no, you put down 0 or 1. Rome, you put down 0 or 1, something like that. Um, yeah. Any question about one-hot encoding? No? Um, just give me a second. There are a few girls. They were asking me some questions. I'll be right back. So, all good. If there is no question about imputation or one-hot encoding, yes, going back to that one question that someone asked about when Eda was done with her workshop, the dummy example and one-hot encoding, does it answer your question? All right, cool. So another question was, if there is missing values in encoded columns, what do we do? So um, you start with the missing values in the beginning. You don't start any kind of encoding or whatever it is. You find missing values. You start with imputation. You find out. Here's the thing. This is your first job. You get a training set. You have some missing values. You deal with it first. So either put zero there in case of null, or depending on the feature, if it's numerical, like other numbers except for binary, you have to find out the median and put it there, or something like that. Uh, like let's say yes, of course you can have encoded columns, and then you can start with imputation, but it's something like uh, a bit work around here. So if you already are given encoded columns, you will have to see the encoded columns, like what kind of values they have. If the encoded column has 1 or 0, and if then you see some null values there, then just put 0 in case of null. That is also possible, but I would definitely recommend you to start with imputation first. But if you are given some encoded column and they have missing values, then you just follow the 3 rules, either drop the column or row. In case of, keep in mind, your training size will be smaller, or if it's just a binary column, put 0 instead, which is kind of like a misinformation already. And in case of other numerical value rather than binary, put the median. I mean, there has to be a, you know, somewhere there has to be a line. I mean, you cannot do that much with the training data if you're not provided. Okay, so moving on to, I have another question. If you drop the missing values will influence, yes, but still we should process to have it. Yes, you have to. I mean, there is, here's the thing. Okay, let me tell you a joke about machine learning or data science before continuing. So there was a, I read it in LinkedIn years ago. So there was a job interview. The manager of a project, he asked a, a candidate in his interview that, okay, so you want to apply as a machine learning engineer or a data scientist or data engineer, yeah, something like that. So then the question was, what is 10 plus 7? So that guy said 6. Then the manager said, try again. And then he said, 11. Then he said, try again. Then he said, 10 plus 7, it must be 15. And that is my final answer. And the manager said, you are hired. This is how machine learning works. You don't have like one absolute successful result. You always have to find out a trade-off between overfitting, performance, underfitting, and all these features. So yes, if you drop a column, your training size will be small and it will have an impact on your model. But again, if you don't drop them and replace the nulls by 0 or some other values, it will also have an impact on your model. So you will have to try. It's always like trial and error. This is how you do machine learning or data science. I think Eda wants to say something.
Yeah, I have one addition. So I think what I specifically mentioned, that if you drop outliers, you will influence the data. But what Tanzim said, it's also absolutely true for missing values. So what Tanzim described in imputation, what you can do, you can obviously also drop the values, but what is the best way to go depends on the data, depends a little bit also on what you try to achieve. So there is not one correct answer. So all data has limitations. There is always challenges, and there is usually never one correct answer how to deal with these challenges. So it's always a trial, it's always up to discussion. So it will also not be that everyone decides the same. how to go. And it also depends a little bit. So it's a lot of experience. It's a lot of maybe also trying out. So creating not just one model, but several. So you try this, you try that, you try something else. And then in the end, you have not one answer, but maybe you have a range of answers. And so with outliers, this is one thing you have to deal with, or with small groups, for example, if you have too little information. And with the missing values, it's another problem, a challenge you have to address. Sometimes it's easy. Sometimes you say, okay, I'll just get rid of it. Sometimes what Tanzim said, it's easy. You can put the median, or you can put this or that. And sometimes you just do the best you you just find an acceptable solution. So that's so it's really something, it's always something to think about.
Exactly. I mean, yeah. If it would have been so easy, we could have just like, Google. We do Google a lot, but you always have to understand that it is still a new science. It's still happening, and you are in the middle of it right now. So moving on to my next feature engineering point, data extraction. So this is very important. You will always have dates, because I don't remember if I ever had any data set without date. Date you will always have. The problem is, it doesn't matter what kind of date format you are using. It can be year, month, day, or day, month, year. It doesn't matter. First of all, yes, it has to be uniform. It has to be either one format all over. That is that is like the first prerequisite. But even then, the machine learning algorithms, uh, they can just build any kind of ordinary relationship if you just have a date and time format. So you need to manipulate the date formats. So how do you do it? You do it very easily. What you need to do is you need to find out the days. Let's say you have date to from. Don't just use the to and from, two dates. Use one column. Instead of two columns, to from, you just calculate the days in between. So this is like the first step that I would do. You can also put it into month, you can also put it into year, you can also put it into quarters. And what also helps in case of, let's say, traffic data or travel agency or holiday data or airplane data, what also helps is to note if it's a weekend or public holiday or weekday, or in case of, let's say, uh, traffic data, if it's office rush hour or not. Okay, so this is what you have to find out yourself from the date columns. You get the date and time. That's how you gathered the data from a survey or something. But as a data scientist, it's your job to find the meaning out of it. So how do you find the meaning? You don't just skip the to and from there. You calculate the days, you calculate the hours, you create extra one column with a flag: weekday or not, holiday or not, rush hour or not. This is completely up to you. So this is something that you have to come up on your own. This is really important in case of date extraction. So yeah, keep that in mind. And I can give you a tip that this is specifically important because yes, during our datathon, we're going to have a data set where this date extraction would be of importance. So yes, just keep that in mind. It's like important everywhere. I rarely came by any data set where I didn't have to do this. So I'm pretty much sure that you will have to do that too. Oh, my charge is low. How much do I have? Let me see. Oh, 14 minutes. So okay. After this, I think I can do the feature extraction till the end, and then we will take a short break, and I will need to charge my laptop. Yeah, data extraction. We've done that. Grouping. So here's the thing. maybe you still remember I've talked about tidy data. Tidy data is there's something called tidy data principle. I will give you the references later. So grouping will make your data tidy. This is very important. So how do you group your data? Again, categorical data. What you can do is you can create a pivot table. So what you do, like if you have, like on the left hand side, you have this example of the table, like user ID 123, and they've been to Rome, Madrid, Istanbul, and how many days they visited. So you just use a pivot table and you just group it. Okay, user one was in Istanbul for 3 days, and user one was in Madrid for 1 day. So you just transform the data and group it so that you have exact compact data, user one, two, three, cities where they've been, and the number of stays. So this is very important. And if need be, what you can also do is you can apply one-hot encoding. So if you remember, first of all, you do imputation, deal with the missing value, and then you do one-hot encoding. And once you've done that, the grouping the cat for of categorical data becomes easier. So there is a relation how I planned the whole outline. So imputation, one-hot encoding, and then data extraction, and now you have grouping. Because once you have done that one-hot encoding, the grouping becomes very easy. So grouping is very important. And obviously there is also numerical grouping. Um, the numerical grouping, it depends of the meaning of the feature. So if it's about, I don't know, um, yeah, a GDP or something. In that case, you will sum up all the months and make a yearly grouped table. If it's about, I don't know, average age of childbirth, then you will use mean or average. If there's something like salary ratio between male and female workers, then you'll use ratio. So the numerical grouping, it's completely up to you, and it's completely up to the training set. And obviously it has to, yeah, it depends on the meaning of the feature. So if you know that, okay, it doesn't make any sense to find out the average of something, then you don't find the average, you do something else. If you see that, okay, we actually need sum, then you need the sum of the data, not the average. But always keep in mind, if you're using average, always use average with caution, because average is not robust. If you add one line, one data point, the whole average of the whole data set changes. So that's why I'm a more fan of median. So keep that in mind. But depending on your feature, depending, yeah, Eda is, yes, me too. Depending on the
Sorry.
meaning of the feature.
I didn't. I should have used the raised hand. I just wanted to add to the slides of workshop 3 and 4. I added this, the robust versus the non-robust, and especially mentioned. I showed. There's also one example that shows this. It's so easy to see if you just try it out once how sensitive to outliers is the mean, and how in comparison robust is the median. And for basically any statistics that is sensitive, you have the robust equivalent, and this is holds also true for most methods. So if you have a method that is sensitive to outliers, you usually also have a robust method. So in case you have extreme outliers, you can switch methods, of mostly often at least. Okay.
Okay. So I'll start again. Oh my God, why does it go back to the very first slide? Okay, so we were at grouping. All right, now we are binning. So binning is pretty, let's say, it's really easy. It's not that, like, it's not that bad, but the thing is, um, it's not that difficult. So binning is simply, if you have lots and lots of data, you might want to find out a range. Okay, So it makes the model more robust, and it will always prevent overfitting. So if you have a lots and lots of values, you might need to find out a range like low, medium, high, something like that. The only problem is there's a cost to performance because you have to sacrifice the information. So let's say um, uh, in case of let's say doctors information, health information, so we have children. So what we do is before below 18 they're all minors, so below 18, so even there we also have like some binning. Okay, children, let's say the COVID vaccination, children from 0 to 12 years, they're like children, and then from 12, in some countries it's even 14, we don't know. So there's like a binning thing, so you have very young children as low, and then you have something like medium, or something like that. So these are like different categories. What you do is you're also transforming numerical data into categorical data. And if you have like a huge sparse matrix, lots of overflow of values, if you feed them all to your training model, it will definitely result into overfitting. So that's something that you don't want to do. In that case, I would definitely suggest binning. Yes, exactly. So yeah, the trade-off between performance and overfitting, that's the key point. So again, machine learning is not an absolute science. You will have to try, and like, again, trial and error. You have to try, so you see like, okay, you don't bin all the ages or all the values. You train your model, and then probably it's an overfitted model. So okay, what to do now? I can do binning. So you bin them, and just an example how you can do it. Yeah.
So I think now we lost Tanzim. I guess she will be back soon. So maybe we just have a 5-minute break again, and then she will hopefully be back. Oh, yeah, she's calling me. Just give me a second, and then like if you okay, so 5-minute break, and then Tanzi will be back with the charger and or charge laptop. Okay, a notebook. Okay, see you soon.
I'm back.
Hello.
Hello, I'm back. So sorry for the interruption. I already yeah, George left. Okay, so we were talking about beaning. So any questions so far? We have talked about imputation. We have talked about one-hot encoding, data extraction, grouping, binning. Yes, that's exactly where before my charge was gone. Yeah, exactly. The example that I wanted to give you was the numerical binning example would be something like this. Like if you have a value, something from 0 to 100, you might need to, well, here again, you need to have some domain knowledge. So you can't just randomly say, okay, 0 to 30 is low, 31 to 70 is medium, and 71 to 100 is high. So what are you going to do if it's blood pressure? You can't just bin them like that. So you do need some sort of domain knowledge for this. So be careful if you're doing the binning, especially in case of numerical binning. The categorical binning is relatively okay, relatively easy. So it's just simply an example: Spain, Italy, Chile, Brazil. Which continents do they belong to? You can also like bin them. Okay, Spain and Italy, or in Europe, Chile and Brazil, South America. So also into the World Happiness Report, the example that you have on Kaggle, you can always like, there's also this being example. So if you're doing some sort of prediction, if you're doing some regression or classification, I would rather use both. First, use country, and if you're like, okay, this is overfitted, or I have no idea what's happening there, or maybe Europe has similar characteristics within the countries than countries in South America, then probably binning is a very good idea to start with. So the last feature engineering step or measurement measure that I want to show you is feature split. Feature split, it is also it also contributes to the tidy data principle. So just like one example, you have one example here on the slides, but another example is on Kaggle, Titanic data set. This is very, very, well renowned, and people know about the Titanic data set. Like all the passengers who survived and did not survive during the Titanic, when Titanic sank. So they also have something like a ticket. So the ticket itself is a string, but the ticket, there is a part of the ticket that says which class do those passengers had, which kind of ticket that is. Is it like an A deck ticket, or B deck, or C deck, or like is it first class or economy class, or something like this, or third class, something like this. So that class or the decks, those are not uh, explicitly written, but those are inside the ticket number. So in that, feature suite is very important because, yeah, of course, during that time, the first class passengers, they were actually, well, they got they got to go into a lifeboat first, then the third class passengers. Again, here in this example, let's say you have Toy Story, Jumanji, or other movie titles. And the movie titles, they always say, let's say Toy Story, we have multiple Toy Story movies in 1995, and like we also had a recent one. So in this case, it's actually helpful if you can split the feature, if you can split it into 2 or 3, depending on the string. How many information do you have in that one column in your raw data set? So I think there is a, yes, you can call it that way. You can categorize the data, but I would still, I won't call it categorizing. I would still call it binning. The thing is, like, it is kind of categorizing, but we have to maintain a convention of calling a method. So like, okay, we call it binning. So next time, if you hear the word binning, you know what we're talking about. But because data scientists didn't talk about categorizing, they talk about binning. And I'm pretty much sure that our next workshop, you will hear about binning again. It's binning, like in a bin. Of course, it's a category, but the conventional terminology is binning. Yeah, there are also other methods how to handle outliers. Do you like, there is this thing, like, do you cap them or drop them? Do you like disregard the outliers altogether, or do you take them into account? There's a lot of transformation, especially for networks, for graph data set, because well, we're not talking about any kind of networks or graphs in these workshops. So there are, let's say, there are different kinds of networks. There is random network, there is hierarchical network, there is a scale-free network. Especially for scale-free network, the degree distribution. So in case of a network, you have a node that's source, and you have vertices. Yeah, you have different arrows outside the node. So that is the degree distribution. So if you have, let's say, let's call a hub. Let's talk about Frankfurt as an airport. So, and let's take some other country. Yeah, here, Tenerife, as for example. These two airports, Frankfurt has way more inbound and outbound flights than Tenerife. Frankfurt is a hub in Europe. Let's call it that way, or Amsterdam. They're hubs, airport hubs, and hubs in Europe. So they have way more outgoing and inbound flights. So the degree is how many outgoing or incoming, depending on, there's like in degree or out degree. So how, from one node, how many routes you're having outside. So that's the degree in terms of network definition. So in those cases, if it's a scale-free network, the degree distribution, you cannot, if you have a linear, if you plot it in a linear way, you will just go crazy. It doesn't make any sense. In those cases, you have to do a log transformation. So 10, 100, 1000, then 10,000 in that scale. Yeah, and then again, talking about scale, like log transformation, and then you have the scaling. You can all do it. Like, there are lots of other methods. Target encoding, if maybe you need to encode your own target. If it says like something, I don't know, which is completely, again, like a long string, lots of data in your own target, then maybe you need to split the target. Maybe you need to encode your target. There are lots of other methods. You can take a look into it. And yes, I can show you some references. Definitely take a look into towardsdatascience.com. These are very helpful. And yes, Stack Overflow is something like the Bible for any developer. I can tell you that I have learned way more through Googling or through Stack Overflowing than in my university. It happens because your university degree is just like absolute degree. Once you're done, you're done. You don't grow anymore. But the rest of the world is growing. So you keep on Googling and you keep on developing. And yeah, Stack Overflow is very helpful there. Then the tidy data, I've been talking about tidy data. Maybe you should take a look at this paper about tidy data, then you will understand. Also, Cal has one whole course on feature engineering. I did not, I did not the whole thing, my whole presentation according to Kaggle, because they also explained the k-means clustering and principal component analysis there. We haven't talked about it. That's why I did not design my presentation in a Kaggle way. But k-means clustering or principal component analysis is a bit more advanced, but I would definitely recommend you to take a look at the Kaggle courses. Okay. So if you have any questions, this is the time. Otherwise, I will go forward to decision trees. And for decision trees, the slides I'm going to show you is not trivial. I'm still calling my feature engineering slides a bit trivial than my decision tree slides, because you will definitely need a calculator for that. You need to calculate log values. So if you have any questions, this is the time, or else going forward. Yes, last time when I was really sick, and yeah, I wanted to tell you more about decision tree. So decision tree is really important because you will, well, currently you will have more success with the random forest or boosting, but the basic is decision tree. So what I'm going to show you is the mathematical basics of decision tree so that you understand how a decision tree works. But when you are programming, when you're coding decision tree, of course, you don't have to understand everything. The code does it itself. The library, you just call the library, you do some splits, you do some pruning, you try with the parameters, and that's fine. But what is behind the whole thing? I have done this with an example. This is a very famous example. Let's go play tennis today. So you have here the training data for 14 days. You have one column that's feature forecast. And these are attributes. Sunny is an attribute, overcast is an attribute, rainy is an attribute, and then again, overcast, sunny, sunny, rainy. These are attributes of the feature test. Then we have temperature, hot, mild, cool, and etc. These are attributes. The hot, mild, cool are attributes of your temperature. Then we have another feature, humidity, high, normal, high, high, like two attributes. Then we also have wind as another feature, weak, strong, and etc. Now, the last column, that is our target, tennis decision, yes or no. That is our target. Our job is to predict the tennis decision with the help of the training data for 14 days. So we have 4 features. So one feature is forecast. So we have sunny, overcast, rainy, 3 attributes for forecast. We have temperature as a feature. We have hot, mild, cool, 3 again. Humidity, we have high and normal, 2. Wind as a feature, we have strong and weak. And the tennis decision, either we go play tennis or we don't. Far so good? Okay. So here's the thing. So I have put the table on the top right so that you understand what I'm doing here. So we have a set T of training objects. That's the table on the top right. And then we have a disjoint complete partitioning, T1 to TM. So partitions. So we have all these partitions. So what are the partitions? A partition is like all the rows. Just give me a second. Yes. So wait, I jumped a little bit too much. So we have things you can see here in the figure below, and the relative frequencies of the class in T in your training set. So let's say C is the class, which is we're doing a classification. So we're classifying the tennis decision. That is the classification. Are we classifying the whole decision to a yes or a no? That's classification. The frequencies is, let's say in case of forecast, let's take this example, the left example of forecast feature. So if you can count, you see there are 14 observations. How many times is there a no and how many times is there a yes? So we see if you look at the attribute forecast, the partition here, you see there is written 9 plus and 5 minus. What does it mean? 9 plus means just count the green boxes with yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 14 days, the decision was yes 9 times. So that's 9 plus. And 5 times in 5 days, we decided not to go play tennis. So zero. So this is represented as 9 plus and 5 minus. Okay, so that's the frequency. So that will be like 9 by 15 or 5 by 14. That would be the frequency. But right, 14 days, we decided 9 times to go play tennis, and 5 times we decided to not to go play tennis. So let's take the feature forecast. So we have 3 attributes here: sunny, overcast, and rainy. So let's see if we take the sunny route, if we take the sunny branch. So in how many sunny days did we decide to go play tennis and did we not decide to go play tennis? So case of sunny, we see the first 2 days we did not decide to go play tennis. Okay, twice, that's a no. If we go further, on 8th day, it was sunny. Again, we did not decide to go play tennis. So again, no. And then on 9th day, we said yes. On 11th day, we said yes. And that's it. So if you follow the forecast feature and follow the attribute branch sunny, you see that on 2 days, we decided to play tennis. And on 3 days, we said we will not play tennis. And then you look at the overcast attribute and the column forecast, and you see how many days was it overcasted where we decided to play tennis, and then how many days we said no, we will not play tennis. Is this clear to you? This is really essential that you understand these branches, this figure. So I'm going to stop talking for a while. I just explained you the forecast feature with the 3 attributes: sunny, overcast, and rainy. And you have the table on the top right corner of the slide. Just take a moment, internalize it, what I just said. I'm going to give you some time, and then I will also take questions. This is really essential that all of you understand this. Who did not understand? Can you please raise your hand? Trust me, if you have a feeling that, oh my God, I'm not understanding it, most probably 80% of others are also not understanding. So just like raise your voice, raise your hand, and just say, I don't understand. Yes, this is a training set. This is a training data set. I go back one slide. This is your training data. This is your training data. These are labeled your tennis decision. This is labeled classes, yes or no. Okay. Object and model. The thing is, your model, you're still not there yet. And this is your data set. This is not even object. This is nothing. This is just your data set right now. Yeah, why no and yes. These are the observations for 14 days, day 1 till day 14. And depending on the forecast, temperature, humidity, wind, it was just a decision. Yes, we go play tennis or we don't go play tennis. This is just a record of 14 days. Our job is to find out a prediction that, okay, given the forecast temperature, humidity, and wind on the 15th day or any given day later on, whether the group of tennis players will decide to go play tennis or not. Yeah, probability problem. Have fun solving the prediction as a probability problem. Uh, uh, please, no, it is not a probability problem. I'm going there. You will understand why it's not a probability problem. So the PI and CI. So the PI is the frequency. You see the PI here in this case, for case of forecast, you see the 2 plus, the 3 minus. This is PI for yes and no. Just the orientation would be the plus sign is for the decision yes, and the minus sign is for the decision no. So we have 2 classes. The class is the decision of playing tennis. Is it a yes or a no? So that's C1 and C2, C yes and C no. And the PI would be P sunny, overcast would be P overcast, rainy would be P rainy. Frequency of sunny, frequency of overcast, frequency of rainy. Maybe, is it slow? Am I glitching? Can everybody understand this? If you have any other questions, okay, let me explain again with wind. Okay, if I'm glitching, okay, give me a second. So maybe I'm turning off the video. That should be a good idea. And this should be better now. I turned off the video. So, okay, I turned off the video. Okay, so again, we take the feature wind. So our classes are, our class is always, it's about classification. So our decision is yes or no to play tennis. So the class is always yes or no. So the CI here is either C no or C yes. We have 2 classes here. And the P is the frequencies of each attributes. So if we are in the partition wind on the right side, so see on the top of the wind, the classification says 9 plus and 5 minus. So it's in all cases, in all 4 features, you see there's always 9 plus and 5 minus, because on 9 days we wanted to go play tennis, and on 5 days we decided no, we don't want to play tennis. So these are the classes: C yes and C no, C1 and C no. So in case of wind, in this case, for this feature, we have two attributes. There can be weak wind or strong wind. So what we do is, in case of weak wind, what is the frequency here? So if we go to the table under the column wind, and we see week, on how many days where we decided to go play tennis when it was weak wind. So on day 1, week, no, that's a no. Day 2, day 3, week, yes. 4, week, yes. 1, 2, 3, then 4, 5, 6. On 6 days when the wind was weak, we decided to go play tennis. So that's why we have a 6 plus here. And then we go again. Week, we decided to play. No, we did not. 2. So on 2 windy days, or on 2 days where the wind was weak, we decided not to go play tennis. So if you follow the wind, the feature wind, and you go to the left branch with the weak attribute, you see that on 6 days we decided to go play tennis, and on 2 days we did not go play tennis. Is that clear how this branches are created? So if you take one feature, let's say wind, weak, strong. So on 6 days we played tennis, on 3 days we played tennis. So this is 6 plus 3 is 9. You can see the 9 plus on the top of the wind bubble. And on 2 days we did not play tennis when the wind was weak, and on 3 days we did not play tennis when the wind was strong. So -2 and -3, that is -5. So you can also see a -5 on the top of the bubble. Okay, so this is really essential that you understand this splitting. Now, moving on, here comes the calculation. We find out the split strategy. What we first need is entropy. How do we calculate the entropy? So a little bit more explanation on the next slide. So for now, you just mind this formula. This is the formula for entropy. So you have the relative frequencies of each for all of these features, all the frequencies of every attributes, that is your pi, and then you multiply it with the log on the base of 2. Always, if there is a log, it's usually in science, it's always log base 2. And you have your observations starting from I is equal to 1 till k, and you sum it up and with a negative sign. This is the formula. Don't ask me how they came up with it. I'm just showing you. And I'm also showing you how do we calculate the entropy of this whole observation here. Yes, the entropy formula, in case of decision tree split strategy, this entropy formula is the same. So just showing you the formula here, and also understand if the frequency is 1, that means yeah, it's a yes in this case, then the entropy becomes 0. And if it's like uniformly distributed, like let's say if wind, let's talk about wind, weak and strong, if we see that 50% of the time we go playing, doesn't matter if it's weak wind or strong wind, in that case it's uniformly distributed. In that case the entropy becomes 1. In case of forecast, we have 3 attributes, so it doesn't matter if it's sunny, overcast, or rainy. If it's like 1/3 of the time we did go play tennis, then the entropy becomes 1. And if we go play tennis every day, depending on the class, for any class, C1 or C2 in this case, C no or C yes, then the entropy becomes 1. So I will go back to this slide again, but let me go through the next slide. So let's find out the entropy of our tennis decision, right? So we have these 4 features: forecast, temperature, humidity, wind. Let's calculate the entropy for this first, for this level first. So how do you calculate the entropy for it? Again, here is the formula. So you have 9 observations out of 14 observations where you decided to go play tennis. So that's the relative frequency, 9 divided by 14. And then according to the formula of the entropy, log 9 by 14. And here you have the summation the summation sign. So we have 2 observations here because we have one decision yes and one decision no. So first we put the decision yes or no, it doesn't matter. Um, and then this calculation gives you 0.940. So if you have a calculator, please put it down here for forecast or temperature, humidity, wind, it doesn't matter because it is calculating the tennis decision here. We have 14 observations. Out of 14 observations, 9 times we decided yes, and 5 times we decided no. And just simply put that into the formula, and then you get the entropy of the decision. So here you see on the bottom figure, that the most bottom here in the end, the entropy everywhere, it's the same because it doesn't matter. It was our decision. It doesn't matter at this point whether it was depending on forecast or temperature or humidity or wind. But right now, the entropy is 0.94. So if you have questions, please, I understand it can be a little bit tricky for some. For some, it's like pretty easy. You understand? Yeah, you see the formula, you get it. So whoever has questions, please raise your hand or ask me because you should understand this after the workshop. How I calculated the entropy here. Okay. So I'm proceeding to the next slide. So here you will learn another terminology, which is called information gain. So information gain is actually, it's about an attribute. So let's say the information gain of an attribute A with respect to T, which is my partition, is defined as this formula, which is based on entropy. Yes, we have to calculate for each feature. So at this level, we have not calculated for any feature at all. We calculated the entropy only for this tennis decision, yes or no, the class, yes or no. The entropy is here, but I mean, you see, like again, we said 9 times, we decided yes, so let's count the yeses, the green ones, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided by 14, because we had 14 observations, that is our relative frequency for yes. And then we count the no's, 1, 2, 3, 4, 5. 5 times no. That means in our 14 days, 5 times we decided not to go play tennis. So this is how we find out the frequency, the PIs. And this is the formula. You put down the frequency, multiply by the log of the frequency, and you sum up all the frequencies together and with a negative sign. So this is how you calculate the entropy. So first of all, you have the entropy here right now.
You calculated entropy for each of the feature I see, forecast, and then
Yeah.
temperature and humidity and wind. Would we have the same entropy for each of the feature? And
Wait,
that is
wait,
the
wait,
that
wait,
is
wait.
the is that an objection?
Wait, the thing is, like, this right now, we still haven't decided because we are concentrating on the 9 plus and 5 minus. It doesn't matter if we still haven't gone down to that level to analyze the forecast or temperature or humidity or wind. We are right now in this slide, we're still looking at the decision. But yes, on the next level, we will have to calculate this also for each feature and each attribute. Yeah? So
Okay.
I'm coming there. Just one slide, just before the entropy, I wanted to show the information gain. I'm sorry for my mistake. I wrote down informational. I don't know what I thought. I wanted to write down information. I'll correct it and then upload it. So entropy is not our main point, but our main point is information gain. How much information do we gain from all these attributes that contribute to our decision-making process? So to understand the information gain, we need the entropy. So this is the formula for information gain. So here, getting back to your question, here we calculate information gain. So let's take wind, for example. Here, the bottom one, information gain. So we have the formula for entropy. We have the formula for information gain. Okay. So that means we have to find out the entropy for wind, for weak wind and strong wind. Here you see, we have to find it out first. And once we do this, so the entropy of T, the whole entropy is 0.94 as we calculated in the beginning here, right? The entropy for the decision making, yes or no. So this is very important. So once we have done that, we take that value, this 0.94, and then we deduce it. Here you see a minus sign, deduce it by this from this, we deduce this part of each feature and attributes. So this is just a mathematical formula. You can simply, you need to take some time, maybe 15 minutes for these 3 slides. You have to do a little bit of self-study, like a little bit of thinking. The formula is there, the values are there, the branches are there, the observations are there. All you need to do is to just put some time into it and find out okay, what is happening where, just like here, as I did here, how I calculate the entropy here, entropy of the whole observation of the whole training set, which is 0.94. So exactly that is how you find out the entropy of each attribute of each feature, and then you sum it up and deduce it from the total entropy, and then you find the information gain. So the information gain T forecast, it means how much information do you have of the training set with respect to forecast. Now you see it's 0.246. For temperature, it's 0.029, humidity, and then and wind, and so on. So where do we have the maximum information gain? Where do you have the maximum information gain? What do you see?
The forecast one.
Exactly. So what does it mean? It means, you're right, from forecast, this is all mathematical formula. There is no interpretation here. It's something like 1 + 1 is equal to 2. It's completely mathematical. You can find out where do you have the most information gain. And yes, you're right. You have, forecast will yield the highest information gain, right? So what does it mean? It means if you are thinking about taking wind into account, it will not give you that much information about your decision making. If you take temperature as your decision making feature, it will also not give you much information about your decision making. So what you have to do is you have the features, and then you see the attributes in the feature. You find out the information gain out of the features, and then you concentrate on that feature which will give you the most information. So if it's humid or windy or temperature, in this example, that's not that relevant because they will not give you that much information. The most information that you gain is actually from forecast, and this is mathematically proven. This is how decision tree, that the split strategy works. This is how like the decision making behind um, the machine learning model will work. So yes, so you will have this will be your final decision tree. Well, you don't have to do the calculation yourself. What you will have to do is you have to feed this information to your machine learning program. They will do it themselves, but this is it's a good thing so that you understand how it's happening, because machine learning model, these are not artificial intelligence yet. Sometimes you have to you know invest your own intelligence, and this is how you can find out, okay, is my model taking the correct feature as an important feature, yes or no? This is how you can do that as well. No, 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 you don't drop them. No, you don't drop them. You don't drop them. The thing is, if you the whole thing can be found out if you have all the columns. Only after, listen, you don't have to do anything mathematically. You don't have to take out your calculators. You don't have to take out your pen and papers. You don't have to do it yourself. The programs, the Python libraries, the machine learning libraries, they do it themselves. You don't drop any columns. And only after feeding this, only then you will find out the significant feature where you have the most information gain. You don't drop the rest. No, if you drop it, because last time we talked about tenfold validation, cross validation. If you drop like at any time of your training, if you drop any column, it will completely skew your result. But you will have more ideas about this whole strategy in your next workshop with another trainer. So finally, so you have 14 observations. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So till 14. So you go to forecast. So you take 40. You make, the thing is, which node is most important? That is the structure of your decision tree. So you see, you gain most information from forecast. So obviously forecast has to be your first level of making your decision, sunny or rainy, right? On or overcast. And then you decide, okay, in case of overcast, so let's go to forecast. We saw on overcast we went to play tennis, overcast we went to play tennis, overcast we went to play tennis, overcast we went to play tennis. That means if your forecast says it's overcast, then on all these 4 days, third day, 7th day, 12th day, 13th day, we went to play tennis. This is an absolute yes. In case of sunny, then you go to, depending on your information gain strategy, because the first information gain was a forecast, then humidity, then wind, then it was wind, then it was temperature. So mostly like temperature doesn't have that much impact at all. So then you go to the first, if you have sunny, then you try humidity, and then you find out high humidity, how many days did you go play tennis, and how many days you did not. And in case of rainy forecast, then you try the wind node, and then you find out the other decisions. The thing is, most of the machine learning algorithms, they do it themselves automatically, and you will have to choose, okay, which split strategy are we using? Are we using entropy? Yes, entropy is important, because without entropy you cannot go to information gain. There are also Gini index, which I'm not discussing here. It will just like, it will confuse you right now again, even more. And there's also misclassification error. There's these different split strategies. I'm just explaining you one split strategy which you can take, and this is how it works. So yeah, I have to like put this reference because I used a few slides from my professor from when I studied masters on bioinformatics. So this lecture is part of knowledge discovery in databases. I took it from there. So don't worry if you're a little bit overwhelmed by this thing. I will upload these slides immediately on Google Drive, on the Drive, and I think the videos is also there. I can upload it by tonight or tomorrow morning. Uh, we will need some time for the video to be loaded on the cloud. Just take these slides and put some time into these slides, okay? Just in these slides. There is nothing hidden here. Here is the formula, and here are the values, and here the values are also there. Okay, so yeah, I'm actually done with my presentation. Just one thing, your next workshop will not take place tomorrow on Monday. Your next workshop will take place on Wednesday, because Saqib, he will explain you the decision tree, random forest, and boosting. He will also explain the entropy, information gain, and Gini index, like how do you do it on a code um, uh, in your program. And yes, that will be, yeah. And after that, on Friday, we will have our last workshop. So I am going to stop my presentation now. I will just turn on my video for a second. If you're a little bit confused, again, don't be confused. This is a little bit advanced, and what you just heard about decision tree, it's actually a master class level. This is not taught on bachelor level. This is actually taught on master level. I'm just giving you a glimpse of this. So the whole workshops and the datathon, it just, yes, Tasnia, the next workshop will be hands-on. That will be hands-on. So the motivation here is just to give you a glimpse and just to motivate you towards data science, data engineering, and so on. So just like, don't think, oh my God, I don't understand anything. I'm pretty sure that you're gonna do fine. You're gonna be quite fine during the datathon. But sometimes I get lots of questions like, hey, I want to be a data scientist. How can I be a data scientist in 3 months? With the tutorials and everything. And I just feel like depends on your background. If you are from computer science background, if you have some robust programming knowledge, yes, or some statistics knowledge, yes, you can be a data scientist in 3 months if you're working every week for 40 hours, if you're like training and learning 8 hours a day. But don't be fooled if someone says, hey, data science, it's easy, just learn some R, some Python, and then you'll get the hang of it. It's not that easy, because we hear that big companies, they pay a lot for data scientists jobs and everything. Trust me, the big companies or any company will not pay you six-figure salary just because you can do import NumPy or Panda as PD. Just for doing those, they won't be paying you that much. It is just like giving you a basic so that you get the idea of it, so that you get the fun of it, and then you like start building up on your basics, and you go to advanced level and everything. Ah, so the COVID, someone is asking if I could provide the COVID mental health data set of the previous datathon for practice. Yes, of course I can. I will upload it to the Google Drive, the same Google Drive as the workshop. You can do that. You can try it. You can try it out. And one thing I can also tell you that the data set that we have for you this time, it's going to be time series prediction. So you will need to understand time series prediction. And on the last day, Carolina, she will explain evaluation and validation. And after she's done, I will explain time series, just some things that you will need. So if there is no question, then um, we had Carolina joining here, but she left. She had to go. We also had Sakib joining here. He left as well. And Farhana Hassan was also there. We kind of like overdid it a little bit for half an hour. My apologies, because I was supposed to cover up quite a part of it during the last workshop. I was sick. I couldn't do it. And well, what can I say? How can I apologize because I got sick? I mean, it was not my fault. Anyway, apologies and thank you so much for your patience. And as usual, so how about the teams? Are you making teams? Yeah, I shouldn't even apologize. Thank you, Tasnia. But are you making how are you going on with the teams, the team building? Because on Friday, that is our last workshop, we will spend some time about talking about the teams, like how far are we? Because I don't see that many registrations yet. Let me have a look. Please ask around, make your team. Let me take a look. How many teams do we have? We have only one team up until now. Only one registered team. Anyway, build your teams and we will see you on Wednesday again. Okay. And yes, we would love to have some feedback, please. Send us feedback soon on Discord or via email. And thank you everybody for participating. I will end the session now. Thank you, Eda, so much for staying up until here. Thank you everyone
to
from
all of you.
Harwell.
See you soon. Have a good day and night and evening and week.
Bye. And thank you, Eda. It's your Easter vacation. And still that you managed.
That's okay. We found a lot of eggs in the morning. I'm not sure, not sure if so this is a German tradition, but on Easter Sunday the children are searching for eggs that the Easter bunny brought during the night, which is me in this case. so, so I got up at 5 in the morning to hide chocolate. I did it once in the night, but then some animal, maybe a rabbit, ate part of the chocolates. so,
what an irony.
So we are looking for chocolates, and then we eat lots of chocolates and real eggs, which are from rabbits, obviously. They are red and blue and green because
eggs
they are
from
rabbit
rabbits.
eggs. Or bunny eggs. Yeah.
Okay.
So, okay. So see you.
See you,
Bye-bye.
everybody. Bye.